Well, after you say, what do we start with this thing? Changes that yes. Oh, yes. I'm going to make it near around 50. Really good is that. People need anything.
Good afternoon, all. Actually, DGM sir will be joining soon. So once he joins, we'll start.
So we are audible. Are you audible clearly? Am I audible? Hello?
Yes, ma'am. Yes, ma'am. You are audible.
Okay.
So we are about to start, and Secretary Omoyas will also join.
ये नहीं खा रहे आप एक बार सर पार्टिसिपेशन देंगे 44
Respected Secretary Sir, DGM Sir, with your permission, I would like to start the event. Namaskar, a very good afternoon to all of you. Sir, am I audible, sir?
You are audible. You can speak little loudly.
Okay. Sir,
You are audible, but you can speak little loudly.
Okay, sir. Sir, it is my great pleasure to welcome all of you to today's popular talk being organized jointly by IMD and the Indian Meteorological Society Bhubaneswar chapter on the occasion of celebration of 150 years of IMD at Sikha Sandan deemed to be University. I, Dr. Mohanty, head IMD Bhubaneswar. I'm honored to have here amongst us Professor C Mohanty, who is going to deliver the talk, and also Professor P.K. Nanda, Vice Chancellor, SOA, deemed to be University. I request Honorable DG IMD, Dr. Murtuja Mahapatra sir, to welcome and address the audience present both at physical and virtual mode. Thank you, sir. Sir, please. Sir, am I audible, sir?
Yeah, you are audible, but I don't hear. बना हो ना कहाँ गए ये ISSD से कहाँ गए लोग भाई? ट्राइपन क्या करे भाई बढ़ाओ इसको चेक करो
100% साउंड कर
शंकरनाथ को बुलाइए
Yes, was once ago. Or even कुछ ले लो. मैं वहाँ पे.
Sir, namaskar, sir. Am I audible, sir?
Yes, you are.
It is better now. You can continue.
Sir, is it okay, sir?
Yeah, it is fine.
Okay, sir, it's my great pleasure to welcome all of you to today's popular talk being organized jointly by IMD and IMS Bhubaneswar chapter on the occasion of celebration of 150 years of IMD Art Shiksha Anusandhan Deemed to be University. I, Dr. Manora Mohanty, head IMD Bhubaneswar, am honored to have here amongst us Professor C Mohanty, who is going to deliver the talk, and Professor P.K. Nanda, Vice Chancellor, Showa University. I request,
शंकरनाथ को बुलाओ भाई. आप बुलाओ उन लोगों को. आप लोग से नहीं होता है यार.
मनोरमा थोड़ा सा साउंड को और थोड़ा बढ़ा सकता है?
सर मैं थोड़ा सा वो माइक के पास जाके बोलूं क्या सिस्टम?
नहीं, क्यों आंसर करना है? नहीं, अभी तो बोल रहे थे ठीक आ रहा था.
Sir, is it okay, sir? Am I audible clearly, sir?
ठीक है मैडम, ठीक है, इट्स फाइन, ठीक है.
Sir, is it, am I audible, sir?
हाँ हाँ ठीक है मनोरमा, ठीक है.
यहाँ प्रॉब्लम है.
Problem is in Delhi, sir.
ठीक है. नहीं दत्ता साहब को साउंड पूरा आ रहा है कैसे? हाँ. But Dr. Sir is getting good sound from.
I think okay, we'll start. Shall I start? So what are you doing here? Are you sharing something? And why the screen is coming up? Why are they sharing the screen? Please unshare your screen, please.
Okay, unshare the screen.
Yeah, it's fine. Yeah, namaskar. Good evening to all of you.
Okay, sir.
Respected Secretary, Minister of Arts Sciences, Dr. M. Ravichandran. Chief guest of this evening, Professor C Mohanty, Professor P.K. Nanda, Vice Chancellor, Shiksha Anusandhan Deemed University, distinguished delegates for this lecture series, participating in this hybrid event, students, researchers, delegates from academic and R&D institutes, ladies and gentlemen. At the outset, I express my gratitude to Professor C Mohanty for agreeing to deliver this talk as a part of the lecture series being organized to commemorate 150 years of India Meteorological Department. I also express my deep gratitude to Professor P.K. Nanda, Vice Chancellor, Shiksha Anusandhan Deemed University, for his kind presence and providing all support to organize this program in hybrid mode from Shiksha Anusandhan Deemed University. I also express my deep gratitude to Dr. M. Ravichandran, Secretary, Minister of Arts Sciences, for his kind presence and his leadership while moving towards 150th year of IMD. With his leadership, blessings and advice, the meteorological community, along with the ocean community, are marching ahead, scaling new and new heights, and hence providing the service to the nation through the science of meteorology, hydrology, oceanography, and many other allied sciences. We have been organizing this lecture series with eminent personalities, and today we have a very popular lecture on tropical cyclones by Professor C Mohanty, who has been known to almost everyone in the scientific community within India and outside. His contribution towards the numerical modeling with respect to especially the mesoscale modeling will be remembered or being remembered and followed by all the scientists working in the field. He has immense contribution towards the field of cyclones, especially with respect to the data assimilations and customization of numerical models. He has helped in generating the human resources by providing guidance as PhD supervisor, as a teacher, and above all, as an expert in various bodies internationally and nationally. We are privileged, sir, for your presence and consent to deliver the lecture today. And I am sure with your lecture, the young minds will be certainly motivated, and the gaps and opportunities available in the field will be taken care of. And as a community from India, we will all scale new heights and bring glory to the country. Now I request Dr. Manorama Mohanty, Head of Meteorological Center, Bhubaneswar, to offer bouquet to Professor C Mohanty, our eminent speaker and the guest of this evening. I also request Dr. Manorama Mohanty
That
to
university, you have to
offer
pin it.
bouquet
You have to pin it.
to
Okay.
Honorable Vice Chancellor
That pin it
of
so that
Shiksha
instead of
Anusandhan
this display,
deemed
only that will
university.
be this.
उसको पिन कर
Pin
दो ना
करने के.
उनकी यही स्क्रीन को पिन कर दो
This is okay. This is
So now I request Professor P.K. Nanda, Vice Chancellor, Shiksha Anusandhan deemed university, to have the opening remarks, please.
Sir, please unmute yourself, sir. Madam.
Good afternoon, everybody. Am I audible now? Hello. Good afternoon, everybody. Honorable Secretary Dr. M. Ravichandran and esteemed DG Dr. Mrityunjay Mahapatra, and our distinguished speaker Professor C Mohanty, Head of the IMD Bhubaneswar Center Dr. Manorama Mohanty, all our deans, directors, and invited guests, and physically here and the Delhi, also virtually those who have joined for this talk, prestigious talk. It's our privilege to be associated with IMD for this lecture series, and we're fortunate to have Professor C Mohanty, a distinguished professor in this area with us. And also it will be gratifying to listen to such eminent speaker about the very emergent topic on this kind of the climate change and climate variability and the effect which is quite tangible, and particularly the state of Odisha felt just a couple of days back the effect of the cyclone, and Odisha is prone to that. And also many faculty members are involved in this kind of activities of our university, also other places, and the prediction, accurate prediction of this kind of activity has helped the entire nation and also the local here, the particularly the state of Odisha in this at this juncture. I wish this lecture will definitely unravel some of the important issues for the new researchers, budding researchers, as well as give some thought to the mature researchers in this area to collaborate and to delve into the much deeper issues to move ahead in these directions for a better kind of living and protection for the entire humanity. With this, thank you very much. Thank you for giving us opportunity to be associated with this series of talks.
So now I request Dr. Anup Mishra to introduce the speaker.
And I'm very delighted to get an opportunity to introduce our speaker. And we have Professor C Mohanty, who will be delivering a talk on tropical cyclones over Bay of Bengal. Professor C Mohanty received his PhD degree from Odisha Hydrometeorological Institute, Soviet Union in 1978 in tropical meteorology. And after that, he worked for 33 years at IIT Delhi in various capacities, from lecturer to head and professor. And he served in IIT Bhubaneswar for 9 years as a visiting professor in the School of Earth, Ocean and Climate Sciences. Currently, he is serving as distinguished professor in Center for Climate Smart Agriculture of Shiksha Anusandhan deemed to University Bhubaneswar. And Professor Mohanty is recognized for his deep understanding of fundamental atmospheric science, observational studies, and numerical modeling. And his illustrious teaching and research career spans over almost 5 decades, during which he has published more than 340 papers in professional, national, and international journals of repute, besides contributing 7 published work as technical reports and several book chapters. Under his able guidance, 44 students got their PhD degree, and 3 are still continuing their research for PhD under him. And Professor Mohanty has been conferred with many awards and recognitions, such as prestigious Shanti Swarup Bhatnagar Prize, National Award in Atmospheric Sciences and Technology, Biju Patnaik Award for Scientific Excellence, Sir Gilbert Walker Gold Medal, and many more. He is also a fellow of Indian Meteorological Society and Indian Geophysical Union. Kindly join me in welcoming Professor C Mohanty.
Yeah, Dr. Anup missed another identity to be introduced with Professor C Mohanty. Professor C Mohanty is an IMDian. He joined IMD as a senior observer in Paradip. Then he left for PhD in Russia. And thereafter, when he came back after completion, he moved to Indian Institute of Technology, Delhi. So we are all proud, sir, because you belong to IMD at that time. So now I request Professor C Mohanty to deliver the talk.
फिर मैसेज आया
Very good, very good evening to everyone. Outside, I sincerely thank India Meteorological Department, in particular, Dr. Muthunya Mahapatra, who is here, for inviting me to give this lecture. So, my sincere thanks to Dr. M. Ravichandran, Secretary MOES, Dr. M. Mahapatra, DG IMD, Professor E.K. Nanda, Vice Chancellor, SOA, Digital University, Professor Manohara Mohanty, Head of the Meteorological Division in Bhubaneswar, and distinguished all the participants of this evening to one way to observe one of the popular talk on the eve of 150 years of establishment of India Meteorological Department. So what they have said, I acknowledge because this talk is almost is I audible to everyone?
Yes.
Yes, sir.
Hello? Okay. So this is the work what I have done since 1974, so almost 50 years. Various issues, but in particular the tropical cyclones. So therefore, I acknowledge Minister of Earth Sciences, MOES, India Meteorological Department, encourage NSEP, HRD in USA, Purdue University, NCMW, IATM, and many other organizations, including SOA, Shiksha Anushandan, Digital University of Bhubaneswar. So, outline of my presentation is I will give a brief introduction about tropical cyclone because it is a popular talk. Of course, it is known to many of my IMD colleagues and scientists, but being it's a general one, so I will start with some fundamental things. So, those who know this subject, please excuse me. So, I will give a brief introduction, and then I will give the characteristics and uniqueness of Bay of Bengal tropical cyclone. So, I focus Bay of Bengal tropical cyclone in particular because there is many uniqueness of Bay of Bengal tropical cyclone compared to other basins. And then I will give a brief presentation on tropical cyclones in climate change scenarios. Then I will come to prediction of tropical cyclones, both subjective methods and objective methods. In fact, 150 years back when IMD established, it was in Calcutta in 1875, and these are 15th January 1875, and it was the British government at the time, and they faced a lot of problem with the navigation in Bay of Bengal. So that's why they thought that what is that, and we have to study it. So in that way, India is one of the lead meteorological services, IMD. So they started with subjective methods, obviously, because at that time not many observations were there. But now you know that the remarkable achievements are there in prediction of tropical cyclones, both combination of subjective and objective methods. Then I will give a little brief on disaster and impact assessment, and also I'll give briefly something of future strategy with net zero casualties. That is the goal of everybody. So if we see the, this is the period of 10 years from 1991 to 2000, when World Meteorological Organization very extensively cataloged all types of disasters, natural disasters over the whole globe. And this is that picture which shows that the blue one is the hydrometeorological disasters, which are mainly the cyclones, floods, droughts, tornadoes, dust storm, heat waves, and cold waves, and so on. And geophysical disasters like earthquakes, avalanche, landslides, volcanic eruption, and so on. That in the blue color. So as you can see, in all these 10 years, they show that almost 90% people they are affected or killed. That is associated with the hydrometeorological hazards. Similarly, this is the statistics also. Significant damage that is due to various natural disasters. And here also you can see that almost 32% by drought, 30% by tropical cyclone, but droughts also sometimes comes due to tropical cyclones. Therefore, tropical cyclones, as I show further, you can see that the maximum significant damage occurred due to tropical cyclones. Drought 22%, 10% earthquake, and 6% other disasters. Similarly, the people affected by the disasters, it comes that drought 33%, tropical cyclone 20%, and drought 32%. This is a statistics by Business Today that the cumulative economic loss due to various disasters. Here also you can see that the top number, that is the tropical cyclones, that is 1,430 billions. That is cumulative from 2000 to 2019, that is 20 years, and followed by drought and so on. So all these things show that we have maximum loss of life or damage that takes place in manpower as well as financial loss that is associated with the tropical cyclones. So now let us come to the tropical cyclone characteristics. So by definition, a cyclonic storm is an intense vortex or a wheel in the atmosphere associated with intense low pressure areas and very strong winds circulating around it in anti-clockwise direction in the northern hemisphere and in clockwise direction in the southern hemisphere. It is really associated with the rotation of the Earth, and Earth is rotating, and over that we have a low pressure area around which wind is also in a rotating motion. Of course, cyclone has two speeds. One is that rotation around its own axis, that is low pressure center, and the entire vortex that's moving, that is the speed of the cyclone. The word cyclone is derived from the Greek word cycles, each coils of a snake. So if you see that a schematic diagram, you see that like a snake, at the low level that the convergence towards the eye, and upper level that the divergence takes place. So that is the compensation of mass in this column, and this whole vortex, which is cylindrical, so it starts moving, and that is the direction of movement of the cyclone. And schematically, horizontally, if you see the schematic diagram for wind structure that is associated with the tropical cyclone, then you can see at the center we have a low level we have low pressure, upper level we have high pressure, and the subsidence of the mass at the eye center, which is very clear, there is no cloud. But then these are the clouds around that in a circular manner. They are actually thousands of thunderstorms associated together due to convective activities, and that is going on upward motion followed by divergent motion around side. So if we see now genesis of tropical cyclones, it is not actually we get tropical cyclone. Tropical cyclone is genesis is over the entire globe, from 30 degrees north to 30 degrees south, tropical oceans belts, and tropical cyclones are generated only over the ocean, not like extratropical cyclones, which are generated over the land as a mixing or of two land masses, pole mass and warm mass. But tropical cyclones, they generate only tropical ocean belt from 30 degrees north to 30 degrees south, except 5 degrees north to 5 degrees south, because there the Coriolis parameter is almost very visible or below particular equator. So therefore, we don't get any cyclone genesis in 5 degrees north to 5 degrees south. That is surface place in that sense. But then around the globe, for a year we get about 80 to 100 South tropical cyclones. And the number of cyclones over our Bay of Bengal and Arabian Sea, they are only 5 to 6 or 6 to 7%. Out of that, 50% that is 2 to 3, they are become very tropical cyclone with a severe intensity. So this is actually schematically it shows, and it has different basin, and over the Indian seas, Bay of Bengal. Bay of Bengal and Arabian Sea, we see that it is cyclones, but in Pacific Ocean we call it typhoons, and in the Atlantic Ocean it is known as hurricane.
ना एक लेक्चर है गेस्ट लेक्चर आ रहा है जो 150 सिलेबस हो रहा है कुछ करा रहा है.
The favorable conditions for development of tropical cyclones, first and foremost is that warm ocean. So because this is a system where the intense interaction between ocean and the atmosphere and land that takes place. So therefore, it is a really true representative of interaction of land, ocean, and atmosphere. And first condition that sea surface temperature should be warmer, and the threshold value is 26.5 degrees centigrade. So it should be more than that. Then only the tropical cyclone will develop. Then strong convective instability over a large vertical column of low troposphere, because cyclone generally penetrate up to almost 15 to 16 kilometers. So, and it is a mesoscale organization of intense convective activities. As I told you, it is associated with thousands of thunderstorm activities around the cyclone. And another very important condition that weak vertical shear of horizontal wind. That is how it is a uniqueness over our region, because to develop vertically a convective activity, the wind shear should be less. With more wind shear, then it will be tear apart, and then the vortex cannot grow. And that is what happened during the monsoon period over our region. The monsoon time, you know, the low level one wind, that is southwesterly monsoon curve, and upper level where easterly jet. So therefore, there is a strong shear, and we cannot get in cyclone. That's why during the monsoon time. So it has to do with vertical shears. Water vapor drawn inward from far away region, because it is a very area of influence is about 500 kilometers. So, and when cyclone touches the land, it is decayed over the coastal land surface, because the energy source, which is the dry surface system, it will stop because warm ocean is not there. Next. So I will go to a few tropical cyclone characteristics and damage potentials, and I will show how it is unique over the Bay of Bengal. So cyclone characteristics are mainly actually pressure drop, because the more the low pressure at the center, that the pressure drop means the pressure difference between periphery of the cyclone to center of the cyclone. So it is generally we call delta P. Delta P is equal to 1013, which is the mean sea level pressure generally, and pressure at the center of the cyclone. So that difference it shows that how intense is the cyclone. Then maximum sustained winds. The wind and pressure, they are very highly related to each other. Because in the atmosphere, we have two major things: mass and motion. Mass is defined by the air mass, weight of the air mass, which is measured at the pressure, and other is the motion of the air. This motion is called ceaseless motion, because always the motion is going on. But this motion difference, this motion depends upon the distribution of the mass. So therefore, mass and motion in the atmosphere, they are interrelated. And this maximum sustained wind, that tells, and other is the areas of maximum wind, which is generally the I wall or radius of the I wall, and cyclone track, because how the cyclone moves, and cyclone is also associated with very heavy rainfalls. Next. So therefore, the types of potential damages due to tropical cyclones are the following. One is the strong winds, which damage due to structure, loss of power and communication, loss of life, then of devastating storm surges and destruction of vegetation, crops and livestock. And being tropical cyclones is the net of the ocean and having strong winds, so it will lead to the storm surges, and storm surge is the coastal floodings, erosion of beaches, loss of soil fertility from saline intrusions, loss of life, and damage of structures. In fact, maximum loss of life generally due to tropical cyclone occurs in low-lying coastal areas where actually the mass destruction takes place. And third important thing is the heavy rainfall. A lot of rain comes, that's a good side sometimes. So heavy rainfall comes which lead to loss of life, destruction of vegetation, crops and livestock, contamination of water supply, land subsidence, and flooding of land areas. Next. So this is a schematic view of the tropical cyclone in a horizontal plane, where we have the eye of the cyclones, then we have the eye wall, then a rain seal area, and then we have spiraling wind and fear bands, so which sometimes extend up to about 500 kilometers or so. So therefore, as you see that in those cyclones, eye is only 30 to 40 kilometers radius, but it influences almost about 400 to 500 kilometers. And therefore, many times, and this is a satellite picture of 29th October 1999, when infamous Odisha super cyclone took place and more than 10,000 people lost their lives. And you can see that eye of the cyclone, which is very clear, and that many times mislead the people because when cyclone pass through, then we get very strong wind and rain and so on. And then when eye comes, it can be calm. So people think that the cyclone has gone. But then comes the next phase, because that 40 kilometers or 30 or 40 kilometers, radius of the eye. So that takes 2 to 3 hours to pass through sometimes, because when it moves slow, then people say that there's no cyclone. But then comes the next one, because it is a cylindrical type of vortex. So if you see the major distribution of the pressure and wind, which are the most two important aspects of the tropical cyclone, so then you can see that the pressure, that is very large fall of pressure, minimum pressure is at the center of the cyclone, and the pressure and the wind are inversely proportional in that way, that where there is minimum pressure, of course we have minimum wind, but then at the eye wall we have the maximum wind. That is the zone where we get eye wall and maximum wind with high wind speed that define actually the cyclone categories. And next please. So therefore, actually this is a WMO classification which is used in also in India and most of the countries, that there's a relation between stage of the cyclones, like a baby born and grow and become young and then die. Similarly, the cyclone starts with no cyclone starts at the cyclone, it starts with a low pressure, and which define again maximum wind, how much sustained maximum wind, and how much is the fall in the pressure at the center of the system. So low pressure we can deep depression, then deep depression, then cyclonic storm, then severe cyclonic storm, very severe cyclonic storm, extremely severe cyclonic storms, and super cyclones. So these define, as we can see here, the pressure drops at the center as well as the maximum sustained wind in the cyclones. So I'll not go to details of that, but this shows that actually how they are interrelated and how there's the different stages of the cyclone. So therefore, when you get the news and so on, you see that a low pressure develop, then gradually it goes to different stages. Next, please. So the mechanism of sustaining this is a very strong interaction and feedback between the atmosphere and ocean. We need the science to bring the science of ocean and the atmosphere together, and this associated with the feedback mechanism, source of energy for the cyclone is actually warm ocean. Because as for example, if I tell the cyclone like Odisha super cyclone, what was the energy associated with that? The energy can be easily compared the cyclone with the kinetic energy, the strong winds, cyclone is equivalent of 1500 atomic bombs that were used in Hiroshima and Nagasaki. That energy is associated with the cyclone. Therefore, it is long to or we can not possible. Okay, so the mechanism between atmosphere and the ocean, and to some extent also land. Yeah. So as I told, the source of energy that comes due to warm ocean surface, and where from we get the evaporation. So by evaporation, it takes the heat from the ocean and the latent heat, and when it condenses, then it releases that latent heat. So massive condensation of water vapor leads to the release of large amount of latent heat. Then once that is there, it generates the winds, strong winds, and then it starts the evaporation from sea surface. And as the evaporation takes place and more water vapor is loaded, then mass of the atmosphere decreases. Because you know that if a dry air versus moist air, the dry air is heavier than moist air. The dry air is mainly from nitrogen, oxygen, and other constituents, and whereas water vapor is replaced by water vapor H2O, which is molecular weight 18 versus 32 or 28, that is nitrogen and oxygen. So by that way, more and more moisture it is fed to atmosphere, and then it is go on, pressure drop is more, and the system becomes more intense. Next, please. So if we see the percentage distribution of occurrence of tropical cyclones in its different stages, like disturbances, tropical storms, and severe tropical storms, that is given here. TD, that is tropical disturbances. Then you can see that the maximum they occur in the monsoon period, that is June, July, August. But if you see the cyclones, they are minimum or nil during the June, July, August, September. As I told you, that is because of strong winds here in the monsoon with a low level coastal or upper level eastern measure, of course, southwesterly and northeastern. And then we have tropical cyclones, which is minimum during monsoon time, but it is genesis. And severe tropical cyclone, if you see, it has clear-cut two peaks. One is that in April, May, and early June. Then starts the monsoon, and which is reduced. Then we have second peak starts somehow end of the September, mainly October, November, and small part in December. So therefore, we have these two peaks or two seasons of tropical cyclones. One is pre-monsoon cyclones, and one is post-monsoon cyclones. And this is unique because those cyclones is definitely tropical basin, but we don't get anywhere this type of two because we have a monsoon, and that is monsoon may be affected by Bay of Bengal and Arabian Sea. Next, please. This is other basins. You can see the North Central Basin, or you can see that the Pacific, Atlantic, all these basins, they have only one season. The season they start with the summer of that is May, June, and continue up to October also. But only our basin, that is Bay of Bengal and Arabian Sea, though we have number is less, but we have clear-cut two cyclone series. We will face one the pre-monsoon, another the post-monsoon. Yes, please. And though Bay of Bengal is a very small basin, but the cyclones they develop over the Bay of Bengal, they go to multiple countries. India, which get maximum that is about 58%, and followed by Bangladesh, which is about 16%, then Myanmar, which is about 7%, and Sri Lanka about 1%. And also, along with that, we get also a lot of dissipation of cyclones, because if cyclone moves from the warm ocean, but it comes to coastal area, particularly in the month of December, when coastal area is cold, many cyclones they dissipate before having land. That dissipation also quite good number, about 18%. So that is how the distribution, and this is the statistics of about 100 years when 440 cyclones were there, and India got maximum 256. Next. So this figure has a little changed, because this is of 1901 to 105, but after that also we have that. But you can see the coastal belt, generally Tamil Nadu, Andhra, Odisha, and West Bengal, they get Bay of Bengal cyclones, and Odisha and Andhra Pradesh, they get maximum, followed by West Bengal and to lesser extent in Tamil Nadu. Next, please. So if you see the cyclones, they develop generally in the central Bay of Bengal, south, generally south east sector. So generally in the tropics, that is from equator to that of the about 30 degrees, the wind is generally easterly, because cyclone is a, and I told you that is a cylindrical vortex, and like in the water, this vortex moves along with the current. So therefore, mainly it is driven by two things. One is that steering flow, what we call it. The steering flow means basic current in the tropics, that is east to west. Other thing is that the change in the Coriolis parameter. Coriolis parameter, Coriolis force is 0 at the equator and 1 at the pole. So as you go forward, then you go on increasing, that is what we call P by the Y, that is the beta effect. So this beta effect makes it to move northern cyclone in the northward and southern cyclone in the southward. So therefore, mainly the cyclones in the Bay of Bengal moves northwest due to easterly wind and due to beta effect. So that is what in general. But beside that, it is many times it is really very complex. It is depend upon the flow patterns, presence of the high pressure cells, and so on. Otherwise, it must be simple, but nothing is so simple. But simple way to see that is the motion that is associated with the tropical cyclone measured forces. Next, please. And then if you see the casualty due to tropical cyclones, this is a history of almost 300 years. That is 1700 to 2000. In this period, we have many cyclones, but if we take cyclones with a casualty more than 5,000, only that type of cyclones, which are very intense cyclones, with more casualties. Then out of the all 24, that is about 73% cyclones, they are in the Bay of Bengal. Followed by Western Pacific 7, Arabian Sea 1, but Atlantic 1. So that means Bay of Bengal constitutes about 73% of deadliest cyclones having a casualty for that. And I will come subsequently why it is so. And so that's why it is also another unique feature for the Bay of Bengal. And where actually you know that he like cyclone Bhola in 1970, when 3 lakh people, almost 3 lakh people perished. And now of 1999, Odisha super cyclone, where actually we lost about 10,000. Similarly, we have a cyclone Nargis in Myanmar, in 2008, when about 1.4 lakh people occupied. Yes, please. This is mainly due to the storm surface. Because if you see because it is a funnel shape and cyclone moves from southeast to that of the northwest, as I told you, due to general motions in the atmosphere. Therefore, we get the strong storm surges, and that, of course, depends on many factors. Most important is how long the cyclone is there, what is the intensity. It will depend upon also coastal structures. It will depend upon the bathymetry. It's how deeper the ocean. If the more deeper, then churning that will be less effective. So, but if it is shallow ocean water, then your churning due to a cylindrical motion will be quite large. So therefore, you can see that when we can have storm surges of about 12 to 13 meters at the head bay, so it will be only 3 or 2 meters as you go on south part, and that is what is the major factor. And then we have a large number of river systems are there, and delta regions, which is the shallow regions. So therefore, storm surge, generally many people they just wash away due to the storm surges, especially with the tropical cyclones. Yes, please. Very specifically, if I show the Odisha coast, this is a study we have done after 99 Odisha super cyclone. So if you see different districts of Odisha, this is the distribution of the cyclones from 1877 to 2012. Next, please. And you can see the storm surges. But actually, in Gopalpur, if the same cyclone falls in Gopalpur,
Ma'am, we are not able to hear actually.
Yeah. So sorry for the little bit technical problems. So if same cyclone with same intensity, it has a landfall like in Bengal, Gopalpur, that region. If we get a storm surge of about 4 meters per meters, same one if it cross the Baleshwar coast, it will be about 9 to 10 meters. And so also in Bangladesh, because that is again due to the nature of the curvature and also the bathymetry, because you all know that the famous Baleshwar coast, you know that the low and high tide you can go few kilometers inland, whereas it's very shallow, and whereas you go to southward like Ganjam or Visakhapatnam, that region, it's a very deeper ocean. So therefore, the height of the storm surge is quite less compared to that of the northern part. And it associated with a large number of river systems, starting from Brahmaputra, Ganges, and to that of the many river systems in the east coast of India, and also the big delta region. They are very shallow delta regions. So therefore, storm surge, when it falls in the mouth of the river, it can go penetrate to many kilometers inland and inundate the area. So inundation, this is the combined surge and tides effects in wave setting. That shows that how it is distributed from south to north. Next, please. Therefore, with this thing, if you see the uniqueness of Bay of Bengal tropical cyclones, we have two cyclone seasons, which are not anywhere except Indian Sea, Bay of Bengal and Arabian Sea, that is pre-monsoon season and post-monsoon season. Cyclones are of a relatively moderate intensity because the cyclones have moved up larger part, they become more and more intense because they get more time to evaporate from the ocean and get the energy. But in the Bay of Bengal and Arabian Sea, you know, Bay of Bengal particularly, the cyclone exists for few days, not weeks. But if you go to Atlantic and Pacific, sometimes they can be there 1 to 2 weeks time and get more and more intense time. But this is weaker in the Bay of Bengal compared to the other basins. Cyclones lifespan is 3 to 4 days generally, against that of the 7 to 10 days in other basins, and it will contribute to only 5 to 7% of world's total cyclones, but the highest number of human casualties, as I have shown you there, and large stretch of low-lying delta regions, cluster of islands in the cyclone prone east coast of India, with the presence of a relatively large number of river systems, and certain segments of Indian coast are highly vulnerable to storm surges due to shallow bathymetry. So these are the uniqueness of the Bay of Bengal compared to other basins that I have shown you, where we can get cyclones all along the tropical basins. Next, please. So now I'll tell you briefly about climate change and tropical cyclones, because everybody is now concerned with the climate change. So obviously, climate change has a lot of impact on the natural disasters, particularly hydrometeorological disasters. So how it will affect the tropical cyclones? I'll show you few graphs on that. Next, please. So this is a study reported by Webster and groups in Science. So this is for the all basins. And cyclones are divided into different categories, like earthquakes. Category 1, that is very mild cyclones. Category 2 and 3, and category 4 and 5, that is the extremely severe cyclones and super cyclones. So if you see that, then you can see that category 1 almost a little bit decreasing. Category 2 and 3 little bit increase, not so much. But if you see category 4 and 5, that is the extremely severe cyclone, super cyclones, it is increasing dramatically. Quite large increase that you can see from 1970 to 2004. That period, you can see that a sharp increase of the number of categories 4, 5 cyclones. That is, it is a world record. Next, please. If you go to individual basins, Then these are the different major basins, like East Pacific Ocean, West Pacific Ocean, North Atlantic Ocean, Southwestern Pacific Ocean, our North Indian seas, and South Indian. So if you can see that period 75 to 89, that about 15 years, and 90 to 2004, the current 15 years to the past one, then you can see that the number of cyclones and that mature to a severe cyclones. If you can see that, then our North Indian Ocean, we say it is increased by 8%. That 8% are mature, now it's 25%. And all other basins also, you can see that the increase of the severe cyclones. Next, please. If we see our genesis of the cyclones over the different parts of the Bay of Bengal, again here, actually we have taken a longer period, 1901 to 2007, and then blue one is that is earlier period of 1901 to 1950, and the red ones are 1951 to 2007, and then solid one with the number of cyclones, and the bar one that is severe cyclones. So you can see that, of course, North Bay will not show any severe cyclone. The cyclone really is the North Bay of Bengal. In a day or so, it is from the land, like monsoon time, we get monsoon depressions, or they cross the land, they never mature to cyclones. But Central Bay, or if you see the South Bay of Bengal, then you can see the recent years, the rise is quite large in the South Bay and Central Bay compared to North Bay, but the recent years, the rise of very severe cyclones is quite large compared to cyclones. Next, please. Similarly, if you see that I told you Bay of Bengal have two seasons, pre-monsoon and post-monsoon season. If you see pre-monsoon and post-monsoon season, the depression, cyclonic storm, and severe cyclonic storm, then you see that the increase of severe cyclonic storm in the pre-monsoon is about 41%, and post-monsoon is quite alarming, 70% also. So this shows that the increase of severe cyclonic storms are there, though number of cyclonic storms or disturbances are not increasing, but the cyclones with the severity is increasing. In fact, as you know that we have more super cyclone in last 20 years compared to last century, where we have 99 was Odisha super cyclone. Next, please. Then I will briefly on the observations, understanding, and prediction aspects of the tropical cyclones. Next, please. So for this thing, this is a complex phenomena, and it's a more destructive phenomena in the atmosphere. So to have this thing, observations are backbones, because weather prediction is always we call an initial value problem. Unless we have observations, we cannot predict. The observation is the main focus, because it's a very complex non-linear system in the atmosphere. Observations gives us a better understanding. Observation is the problem of engineering, because here we use all modern equipment. Any new thing comes, like aircraft, satellite, radars, any new thing comes, we already use it to deploy to get observations. Because two-third area is the oceanic area, where actually without satellite ships, we cannot take much observations. And so the observations is the engineering problem that we call, and observation is the backbone, and that gives us the better understanding of the science, and that understanding gives the development of the models, and finally the tools for prediction, and which is in the real time, both are there for forecasting methods. So if we see the advance in technology in the weather science, is tremendous advancements, and that is like our mobile phone. You know that how much it expanded, or internet facility, how it expanded in 20-30 years. Same way, actually, we have a global Earth observation system, where we take observation from the Doppler radars, satellites, aircrafts, UAV, radar, ships, buoys, and so on. And these are the science of electrical and mechanical instrument sciences. then the data have to transmit it because there is no boundary in the atmosphere. It will go up. So therefore, data have to be collected and available to every place. And in fact, the data from whole over the world will be available within an hour or so in any center in any part of the world. And that needs a data transmission and processing, that is electronics and communication systems. Then this data has to be assimilated, and so that the data is available in the random places where we have observations. But when you go to modeling, so you have to systematically regular data. That is what we call data assimilation and model integration. That is the science of computer science and engineering. And in fact, I will show you that the all growth of computer modeling is associated with the invent of the computer science. First, Euler Newman Euler prediction was developed in 1948. When Van Neumann and Germany, they have in Princeton University, they started the first use the computer for making the numerical predictions. So therefore, it is the computer science. Whenever any big computer comes, that it goes to atmospheric science. Of course, already the bioscience also nowadays. But it was in India, the largest computer that is available in MOS, that is in Indian Institute of Tropical Meteorology, National Center for Weather Forecast, and also IB. So they get the largest computer same way. So you put in the history of computer and use in weather prediction, it always go hand in hand, because for the numerical weather prediction, we need always demand more and more high resolution, and which is possible with the computer science and computer engineering. Then customization of the products from the models for the users, and that is also done. And then it has to be rapidly distributed to people. That is again communication. That is how the people will get the message in time, or different end users, they can get the forecast. So therefore, you could see, and then when you have to take any measures like disaster management and so on, it is a problem of civil engineering and management of what we do, building structures and all, and then adoption strategy in climate change scenario for sustainable development. So that is again green environment. So therefore, you could see that the atmospheric science, particular, in general, and tropical cyclone in particular, they depend upon all these things. The advancement in technology, that is in the weather science. Next, please. Next. So this is how you can see that the weather satellites, which is using weather and climate, and also the various one pilot plus aircraft and so on, all high technology, and in ocean, the ships and buoys and aircraft, everything is used to gather the observations and communicate in time to the meteorological services. All these things are monitored by the World Meteorological Organizations, and without any boundary, the data is available for all the countries to use it for the weather and climate prediction. So the principle of tropical cyclone prediction, that is, it is the energy is the main source of development. So energy source is the radiation, and the radiation that will be warm of the ocean. So ocean is a good absorber of the heat compared to land. Land is poor, because land daytime heated up, nighttime cool down by radiation. But ocean, top layers, they go on absorbing the ocean, the heat, and when it is enough heat is there, that release to the tropical cyclones and disturbances. So the energy source that is comes from the sun, that is radiation. The forces is the dynamical forces, that is the motion, and the physical forces, that is the physics that is associated with the atmosphere. I come briefly to that. Then atmosphere is very much characteristic by seamless motion, that is the wind. And as I told you, the atmosphere has the mass of the atmosphere, the pressure, but mass is almost constant, but it will be distributed. Someone has more, that is high pressure, someone is less low pressure. The low pressure and high pressure, that deal of the gradients, and this gradient is the motion. So therefore, always that the linkage between the motion and mass. And most important thing in addition to that is the water cycle or hydrological cycle. Our planet is exceptionally different from the rest of the group of planets that we come across that is about water. And this water cycle. So most of the weather, suppose we don't have the water, we don't have any ocean, then most of the weather we may not get. Because most of the weather we get whether it is rainy day or it is clear day. And all this comes due to the water vapor and the water cycle. So that is available in our planet. So these are the major principles for any weather phenomena, in particular the tropical cyclone prediction system. Based on that, the models have been developed where these 5 things are taken care. Next, please. So if we see that 5 things comes, these are the science part. I show you the engineering part. This is a science part which is involved in the development of the models, particularly numerical weather prediction models. That is physical science. That is atmospheric motion, thermodynamics, physical processes like radiation, turbulence, convection, and so on. Mathematical science, which gives the shape to the mathematical equation, because the equations, if you see that are nonlinear partial differential equations, I am not going to that, but it is solved by mathematical tools, that is the numerical methods. Then chemical science also play a very important role, like atmospheric chemistry, composition of the atmosphere, aerosols, greenhouse gases, and so on. Even our biosphere plays a very important role. That's why you call deforestation, desertification, and so on, because biological science also plays a very important role. The biosphere, where we have evapotranspiration take place from the plants, land use and land cover is very, very important. It gives you the change in albedo, roughness, and surface heat balance on the surface. That all depend on the biological processes. Earth science like lithosphere, volcanic eruption, cryosphere, soil characteristics, surface and subsurface hydrology, all these things also play the role as earth science, as environment science, air pollution, water pollution, ecosystems, and computer science, which is actually put all these things to make a computational methods, data mining, parallel processing, activities of the computer, and as I told you, the computer is the backbone of present day numerical prediction. Next, please. So, as you have seen, science and engineering both intimately linked with the development of this type of coupled model systems, and this is a schematic way of their feedback. So I will not go to that, but this shows that how the atmosphere process is feedback by the surface, oceans, and so on. Next, please. This is also different physics that is associated, like actually radiation physics is the most important. Besides that, the turbulence at the surface, then energy partitioning from solar energy partitioning, and convective activities in the atmosphere, where it takes place, the water is evaporated, it makes the clouds condense. The cloud may be shallow clouds, cloud may be very deep clouds like thunderstorm clouds, and also roughness like we have mountain drags and so on. All these things play very important role. Therefore, we call that if we have to understand the science of the weather science, then we need interaction of the lithosphere, cryosphere, biosphere, hydrosphere, atmosphere, and outer space. All they are like no boundary, they are interact. But they interact in the different states. And to put that in the model is always a challenging problem. And many times, those small scale processes like the turbulence, which is actually starts in few centimeters, to atmospheric motions, which is very large. So we do a lot of parameterization and so on things, and I will not go to that. But this is how, so that how the complex the atmospheric system, and that's why the nonlinear complex system, it has a lot of uncertainties, and therefore always whenever we go to the mathematical tools like discretization with spectral models, with finite difference methods, finite element methods, and use of different statistics, including nowadays AML and so on, that is used to understand and predict the processes in the atmosphere. So with this brief, now I will go to the specific example of prediction of tropical cyclones. Because without telling that, you cannot know that what is the difficulty in predicting of tropical cyclones. That's why I told briefly the complexity of engineering and science together. And when you predict the tropical cyclone, generally we see that these things, vector motion of the storm, place and time of landfall, duration and time of landfall, duration of the storm. Because the more duration, it's more intensified in the ocean track of the cyclone storms. As intensity will go through the central pressure or the pressure drops, wind maximums, and rainfall. So this is the increasing quality of prediction for the tropical cyclones. It is a chain of events starting from the detection of the cyclones. Nowadays, actually, we don't miss any cyclones because of the satellite, because most of the cyclones are in deep oceans, and unless there is a satellite observation, so we cannot know when the genesis. Now you know that in cyclone, genesis is predicted in 7 to 10 days in advance. If the Pacific and Atlantic, there will be 10 days, and in Bay of Bengal, in 7 days in advance. That is because of the detection of those things well in advance. Prediction of the cloud clusters, and from that, which is going to grow for the larger to cyclone vortices, and forecasting the movement and landfall of the storm centers as it approaches the port, which is the major things, and that lead to the storm surges and inauguration of the coastlines and so on. Next, please. So there is various methods for prediction of the tropical cyclone trap, and as I told that since 1875, IMD have pursued to predict the tropical cyclone. Obviously, at 1875, there is no communication is not so great, observation is not so great. That kind of synoptic method was started. And first synoptic method in the world started in Paris in 1855, and IMD started in 1875. So that means we are really ahead of many countries, and where actually the forecast process started with the synoptic methods. Then systems move with the persistence. That means how it is moving past and how to look future. Climatology, combined persistence and climatology, that CLIPER is used for many years for prediction of the tropical cyclones. And I told vortex, so steering current, that you have to move the things, and satellite techniques, which is used since 1975 or so on. Expert systems is the most important thing, and for many years, statistical techniques were ahead of the numerical techniques. Almost up to 1980, statistical methods are doing better than the dynamical methods because of our lack of observation and understanding. Only after 80 or so, it is superseded. And now, most of the things you get in the dynamical methods. Of course, dynamical methods always have a lot of scope for putting the statistics. So therefore, we call it a dynamical and statistical methods, or combined dynamical statistical techniques. And ensemble predictions, now you see the striking probability and potential, though they are also the part of the statistics that embedded with the dynamics. So therefore, dynamics and statistics, both with the expert systems, they finally give you that the cone of uncertainty and so on. And in the Indian basin, we started that things only recently, maybe 2006 or so, where we put the cone of uncertainty that which area it is going to cross and so on. Since then, we are using various other methods. Dynamical methods, with the numerical methods I told, it is genesis only 1948. World War first numerical model was integrated in the University of Princeton in 1948. Then after that, it go on and steering flow method, integrated method, so simple barotropic methods, non-divergent methods. So these things were continued up to 1980 or so. Then comes the global models, and then come very high emission models like MM5, which started in 1982, and then WRF, HRF, and so on. They are actually in this 21st century only. So high resolution coupled land ocean atmosphere models still in the development stage in many places. And in India also, we are doing actually, I will tell you subsequently, we are developing a model jointly with the MOS and academic institutions and US counterparts, that is with the IOLA, Indian Ocean Land Ocean Atmosphere Coupled System, because this process, as I told, they are combining those things. So we use the combined dynamic and statistical techniques, and also ensemble and super ensemble, because if you see the models, with one model, with little change in initial condition, it can give different results. That is what we call chaos, we call nonlinear systems, and we call the butterfly effect. Because a small disturbance somewhere, it can propagate to some other place. So because the system itself is nonlinear, so we cannot linearly correlate it. And nowadays, we get IMD forecast to start and strike the probability forecast, which is really a great, because which shows that where you have maximum probability and where you have minimum probability and what is the stage, because that gives you the preparedness. And I remember 2005 when NDMA came, they demanded 48 hours, 50 kilometer error they need so that can be valid. We are thinking it very difficult that time, whether we can achieve or not, so that people can evaluate. Because 99 told that it will come to Paradeep and we support. Not that it pinpointed a cyclone is coming to the Paradeep or go to that cliffs where it is propagated. So now it is all possible, and you have a striking probability of forecast. So I will show a few success stories. So I will show the glimpses of success in tropical cyclone prediction, and that is what I will show you in the Bay of Bengal only. Next. So this is how the things have moved. Actually, history of models for prediction of North Indian Ocean tropical cyclones with the statistical methods. They have continued. Prior to that, synaptic methods are there. And even now, also synaptic is used, but I am not giving that. Statistical methods used extensively up to 1980 or so. Then in India, we started quasi-Lagrangian method in 1980 or so. And then only 1998, 99, we started MM5. Then in 2005 and 6, we started WRF, and with data assimilation, WRF data assimilation. HWRF system, it came almost in 2010, and now we are progressing towards developing a model jointly, that is IOLA, Indian Ocean Land Atmosphere Model. So this is the actually growth of the models in different years, and until 2003, as the daily forecast methods are subjective, and gradually now it is objective, and now you can see that what is the success of that things. And 2008, IMD started a forecast demonstration program of tropical cyclone, where they jointly work with the Indian Air Force, Indian Navy, different organizations, academic institutions. We also participated several years from IIT Delhi and IIT Bhubaneswar in the process of forecasting the systems and providing everything to IMD, and the IMD put everything, and finally they issued a forecast for the nation. So that is how the growth of the modeling systems, cyclone prediction system in India developed in the recent years only. Next, please. So this is actually I'm showing that we track prediction of significant gain with the resolution on physics. One more, please. So the left side one, that's a 99 Odisha super cyclone, and this is the 2013 Halley. So you can see that the force resolution spread in the forecast to that of the present day. That's cyclone Halley, which was predicted continuously 5 days in advance. It is going to flow to Gopalpur coast. So therefore, it gets a time to evacuate the people, and in fact, it made a Guinness record because in 2 days, Odisha government evacuated that time 10 lakh people. It was possible because of constantly giving the forecast that it is going to cross between Chivita, Gopalpur, and that area, which are not possible in the time of Odisha super cyclone 99. So you can see the difference of that, and that gave a casualty of about 10,000, and here it is going about only 20. And out of that, 10 were actually, this is again a enormous source that we have a flood in Suvarnaka, which is North Odisha. Cyclone crossed Gopalpur, southwards. But spiral band with a lot of rain in Suvarnaka, and then it was a flood there, and 10 people died. So 10 people only died due to a super cyclone, close to super cyclone, to that of the super cyclone of 1999. So this is how actually the prediction is the here you can see white is the tracks that is observed, red one that is the predicted. So you can see how nicely the models now can generate the prediction. Every 3 hour predictions is done, and landfall particularly predicted within 24 hours in advance. Yes, please. So these advancement in the forecast of tropical cyclones, mainly I can tell, it is my opinion, establishment of MOES, which was in 2006, where actually they bring all the IMD and meteorological organizations like IATM, INPAS, Ocean Parks, and similarly NCMW. So all IMD family, they come together, and that is under the MOES, which are very specifically focused, and modernization of IMD observation systems. That is around 2006 or so. The establishment of Earth System Science Community and coherent R&D between sister institutions of MOES. Forecast dimension program of tropical cyclones of North Indian Oceans, that is 2008. Close interaction among the operational, academic, and R&D organizations, which took place more coherently from FDP time, that is 2008. And strong international collaboration. We have a strong international collaboration and technology transfer. India, which our partner countries in other countries, particularly NOAA, INSEP, and HRD, and both the places, the head of the cyclone modeling is they are Indian only. So that gives us advantage, because you know that the USA, those who are from Taiwan or China, they always have a focus to help their own country. So we have also some eminent scientists. They are heading the cyclone work, modeling, both Hurricane Research Division and NCEP, and UK Met Office also. We have a collaboration of NCMW with the UK Met Office. So this collaboration and getting the forecast from different countries, that also enhance us to improve the forecast. And then the collaboration and upgradation of high performing computers. That is most important things, because without a computer, it is not possible. So India started a monsoon mission around 2011 or so. And monsoon mission gave also another input to this whole program by upgrading the high performance computing system. Now actually, as I told you, that we have the highest computing system in India, available at IIT Pune, and also in some of the New Zealand. Next. So this is the track and intensity of the cyclone season. So I am showing this one because this is a cyclone where actually we see that how observations play a very important role. I'm showing one. If we are not putting the Calcutta radar, then the cyclone is going in a different direction and it is not leaving a landfall. That is what you can get from. So if you see these two which have no landfall, that is one is without BTS and BW assimilation. One should do that blue one, BW assimilation, with the black one, and it has gone to Bangladesh, which has predicted. So that's why you can see in a single Doppler radar can make a big change to take the cyclone to right place, which was otherwise difficult by the models. So this is how the development have taken place in observations. We have many Doppler radars in India nowadays, and in Odisha we have already Paradip and Bhopalpur and many other places in East Coast and West Coast and other places. Next, please. I will show very quickly the prediction of Halil, that is a tropical cyclone of 2013. After 99, it was one of the largest cyclone in the Odisha region. So this is the prediction which I have shown you that 96 hours before, 72 hours before. The white one is the observed and the red one is the track. That is predicted, and the intensity is shown by the pressure drops at the center. So in that case, after 2013 became 940 millibar of pressure. So that means a very severe cyclone, extremely severe cyclone, and that is how well it is predicted. Please. And this is the Gopalpur pressure drop, that is Gopalpur, that barograph, and then that is the prediction. It was 940 or 938 that was reported at Gopalpur when that cyclone valley crossed. So it was very extremely severe cyclone, and model could be able to predict also that the pressure drop is there. So that a little time gap is there, but it has very well shown that it has a deep pressure drop which is taking place, and a cyclone is approaching there. So along with that, track errors are given from different models, that is again generated by IMD. So you can see that nowadays tropical cyclone is no more it's predicted in India. It is predicted by many centers all over, like UK Met Office, National Hurricane Center, NOAA, Japan, and many India GFS system. So many countries they predict the tropical cyclone and they transmit the results. So this is what you can see, that the mean track errors, how it is reduced, and so also the intensity prediction, and this is the track, that is the same value. Next, please. And this is the rainfall that is associated with the tropical cyclone. As I told you, the cyclone passed Gopalpur, South Odisha. And the rainfall, you can see that quite a lot of rainfall is there in the North Odisha. Because of this style, this thing, and that gave the problem. But 50% people, 10 people they are there, because they are not aware that the problem will come there when cyclone passing to Gopalpur. So these things are possible actually because of the modeling and prediction, and also finally operational used by India Meteorological Department. Next, please. And what casualty is there due to the storm surface? And this time actually we have done a quasi-coupled storm surface prediction. That means we have taken output from the model, numerical model of atmosphere, and put in the ocean models, storm surge, and predict the storm surge. So this is the profile of the striking surge evacuation elevations at different places, starting from Chandipur to that of the Visakhapatnam, and the landfall is near Bhopal. So you can see that that is what is predicted also almost 72 hours before the landfall of the tropical cyclone, that the storm surge of more than 3 meters will be there at Bhopal. Next, please. Similarly, we all know that the Fani also another destructive cyclone which passed through coastal landmass of Odisha. Next, please. So this is the observations or guidance during the landfall of the cyclone from the Paradip radar and satellites. And this is the prediction about 5 days in 96 hours before, that it is coming not only crossing to the Puri, but it is coming to landmass. And you know that the whole was very affected that time. And 3 days we don't have any light and electricity and so on. And this is predicted every 6 hours. And you can see that all the track they are showing 5 days in advance, doing that it is coming to the Odisha coast. Next, please. This is again intensity prediction of certain maximum winds from the cyclones, and this is the storm surge prediction 72 hours in advance due to the tropical cyclone Fani. Next, this is the rainfall associated with that cyclone. Next, similarly prediction of the super cyclone Amphan. So super cyclone Amphan was 13 to 21st May 2020. Next, so this also very well predicted. And here you can see that I am showing also the cone of uncertainty or cone of the track, and also area of certain winds. And this cyclone was super cyclone over the ocean. But at the time of fortunately landfall in West Bengal and Bangladesh coast, it became reduced to a cyclone. But over the ocean, it was a really super cyclone. And that was possible to predict. Again, with the modeling capacity, because there is no observation available. And to achieve that intensity of 220 kilometer per hour, that would be predicted only through modeling activities. And finally, the prediction was so accurate by IMD that it crossed really the point where it is in West Bengal. Next, this is the current cyclone, which was really a cyclone with 0 casualties, and it was successful because of the excellent prediction of the IMD. They are predicted in well in advance. In spite, you see, this is the models. Different modeling in different tracks. So if you pick up one, it will go one side. But finally, to combine that and to make a track of uncertainty that where it is going to have a landfall, is a tremendous expertise required. And now I didn't have that expertise so that they could predict very well in advance that where it is going to have landfall, and actually it has a landfall there. Next, please. Though it was not a cyclone of very large intensity, but still then it was a very severe cyclone, and that is Dana. And this is the two things I am showing you: 22nd forecast of IMD and also 25th October what happened. And that was the black one is the observed. So if she observed and predicted, they are exactly coincide. So this dramatic improvement came, as I told, the various factors, starting from observations to that of the modeling, and finally the decision-making systems, and that all work very well. And this is one of the cyclones leading to 0 casualties. Next, please. So now, what is the challenge before us? Present challenges in tropical cyclone prediction. Next, please. Because rapid intensification process coupled with the ocean models, land surface interaction, shear vortex interaction. These are the major things that which govern the intensity and of the cyclone and the direction of the movement of the cyclones. So these things we have to see how best can be coupled. But still, then what I've done, I will show some success story and I will show that what is the future. So this is 2013. We have 2 severe cyclones in the Bay of Bengal. Of course, many are there. I'm showing you 2 which have drastic rapid intensification and rapid decay also. Like a Thalin, which has a rapid intensification, and where are the cyclone? They have which are the rapid decaying process. Because if you do a wrong forecast, then that leads to lot of loss of properties, and more importantly, loss of the face of the people. But if you predict like a cyclone Lehar, it was a very strong cyclone, but when it have a landfall, before that it has reduced substantially. So this shows forecast length, and this shows that we how this is intensified in the case of the Thalin. It is suddenly intensified. That is the wind speed you can see, and here it is decreasing. As come to the coast as time process, so it is going down. And this was examined by the models. So it has seen that in case of Thalin, you can see that the circle that is observed and the predicted one, it is very nicely that is the wind, and the green one that is the pressure drop. But in case of a Lehar case, then your pressure is intensity of the wind is decreasing, pressure fall instead of fall it is rising. And there is a sudden weakening of the Lehar, which across actually South Andhra Pradesh coast, so that the IMD also told that there is no need of evacuation. It is start of the severe cyclone, but by the landfall it was big difference. So therefore, a lot of health people have generated that they have to not evacuate, because evacuation is not costly, but it has also psychological effect and so on. So it is predicted very nicely that a cyclone also going down, or the intensification is it is weakening. The weakening of cyclone also, that intensity is very, very important aspect, and that leads to all types of evacuation and different measures. Next, please. And then quickly I show that it is possible, because in case of a rapid intensification, you see that the water vapor is increasing in that column, and whereas the weakening case of layer, that water vapor is dry in the middle troposphere by incursion of dry air from the land mass, and that lead to the decrease of the moisture in the column and also decrease of the intensity of the cyclone. And this is what we show that in low troposphere, middle troposphere, and upper troposphere, in case of layer, you can see that it is decreasing, and whereas in case of Thalin, it was intensified. Yes, please. Another thing also, the vortex. If vortex is straight, then it will more intensify and it becomes straight. But if it is tilted, that means there is some shear effect, and shear effect always kills the cyclone. You see that in the case of layer, the vortex is not a straight line, it is tilted. But whereas in Thalin, it is very straight and more intense. So all these things, key things that intensify cyclones, that was predicted also very nicely by the models. Other thing that actually those cyclone in prediction have been remarkably improved, it needs also disaster management to reduce the loss of life. And we should be really proud of Odisha. The Odisha is the first state started a disaster management authority. Nowhere we have in India, though we have cyclone for several years, but first OMA was established after 99 Odisha super cyclone. It was insisted by everybody that Odisha is very prone to cyclones, so we should have a disaster management, not a relief concern. Relief concern was there all the time, but disaster management, pre-disaster steps. The OMA was established in 1999 after good earthquake. 2000 it was in Gujarat, and finally NDM was established only in 2005 with the Act of the Parliament. So these are the very, very essential parts, because with a good forecast, unless we have a disaster management, it will have no gain to get. And the example is the cyclone Nargis. Nargis is cyclone in the Bay of Bengal. Initially, it is coming to the Sinai port, but it crossed the Myanmar. I predicted it very well 5 days in advance. But loss of life about 1.4 lakh there, and
The voice is not audible.
people to evacuate, because evacuation is also very, very difficult thing. And so I show literally one or two things. So that is the comprehensive disaster management system towards zero casualties. That is first is required impact-based forecast and warning systems, which is India Meteorological Department doing. That is with the objective prediction systems and enhancement of observation networks, and then communication and awareness. That is generally the media have to do, and they are doing that now most effectively. Because 99, I remember we don't have satellite telephone, and then our chief minister could not communicate to the rest of the world that we have a super cyclone in this. But now they have the full origin. And then disaster management, as I told you that.
Slides are not visible, sir.
I have only two or three. So I come to the conclusion. So it is not only to state that the establishment of IMD by the East India Company initiatives. It was in 15 January 1875 in Calcutta. It is associated with started with the prediction of tropical cyclone that formed of the Bay of Bengal and impacted the Calcutta port enormously. Now, in the last 17 or 18 years, IMD has really achieved a remarkable success in forecasting tropical cyclones of North Indian Ocean, Bay of Bengal and Arabian Sea. That is what I have shown you, that how dramatically 5 to 7 years in advance the prediction is done with a cone of uncertainty and zone of maximum wind and so on. These major attributors are the enhanced observation systems and modernized IMD, with Doppler radar systems and other things, improved high resolution modeling systems that is introduced in 2006 and 7, increase in the computational resources by the MOS family, interaction among the operational research and academic community, the start of the forecast demonstration project of tropical cyclone, and also international collaboration. So that is the next thing, the mass education and timely dissemination of forecast products through active participation of media, mainly the television, plays a very important role in increasing in communication facilities and involvement of social activities. Last but not, the establishment of disaster management authorities, such as state and central disaster authorities, as I told you, like OSDMA, NDM, and so on, and also endurance, like the National Disaster Rapid Force. Because previously only they are calling the people from Air Force and Army after the event is over to help with some people who are trapped. But now it is done proactively before the event occurs. So that is the, as I told, the 2013, they evacuated 10 lakh people, and the recent one, Ghana, about 8 lakh people before the event occurred. So that is possible due to the NDMA, OSDMA, NDRF, and so on. And enhance infrastructure in the coastal area also, like the road system now, you know that with the prime minister road system, you can penetrate any village because they are complete roads. But I remember when we were children, it is very difficult to take a bicycle after the rain because it was all the muddy roads. So evacuation is not possible. Similarly, the Pakka houses have increased, number of shelters have increased, health facilities in the shelters have increased. So all these things together have substantially improved the life of the people during the tropical cyclones, Middle East, and also leading to towards zero casualties. The future strategies, ground level, because cyclone, as I told, one is the prediction accurately, second is that we have to see that what is the risks and vulnerability associated with that. The vulnerability due to cyclone are mainly the 5, that is your physical vulnerability, economic vulnerability, social vulnerability, infrastructure vulnerability, and administrative vulnerability. All have to be assessed, the risks, and wherever there is vulnerable, we have to take those specific steps. So that step has been also taken, and so for that thing actually we need a lot of intense collaboration, and even the stage of MO, of course there is some collaboration already there, definitely, but it needs strengthening so that the ground level social and economic data need to be communicated between state and central government agencies. Risks and vulnerability assessment for impact-based forecasting and warning, which is the now the slogan of IMD and which is going to success. This needs a close interaction between IMD and local state level authorities. Prediction of a high resolution delayed wind and rainfall associated with the tropical cyclone, so that the rainfall prediction still we have to improve, because though rainfall prediction is there, more accuracy is required. Prediction of a thunderstorm and lightning associated with the tropical cyclone, because as I told, that thousands of thunderstorms are there. Many times people also die due to lightning, that have to be taken care. And development of a comprehensive coupled ocean, land, and atmosphere like IOLA. This system is already started in collaboration with the MOS family, like IMD, INPAS, IITM, and our some patterns, one education institution like Meteorological, and also from USA, HRD, and university level Purdue and also now post-processing and bias correction that can be done using the AI/ML techniques so that it can further improve. So with this, I stop my presentation. So it will open for and thank you very much for your attention.
Thank you very much, sir, for this interesting talk on tropical cyclones or Bay of Bengal. Now, floor is open for a few quick questions. So those willing to ask questions, they may please raise their hand. Participants present physically, they may also ask questions.
And I have a little minor.
Can I ask a question? Am I audible?
Yes, sir, please go ahead.
Yeah, I just wanted to know from sir actually that you know the losses we have significantly reduced the losses of life. So what about you know how to reduce the economical losses, something like that? Yeah, specific to Odisha, I can tell. Is there any attempt? As you know that always the October, November remain the main vulnerability. So helping the farming, because all these, you know, Baleshwar, Jagatsinghpur, Kendrapada, there is a large scale paddy harvesting. So they don't get, you know, any intervention from the government. So is there any attempt for mechanical harvesting of the paddy? That is number one. And is there any campaign or thought? That is number one. And number two, what is the restoration back to the normalcy, particularly the service sector actually, like electricity, all these who are impacted. Like if we take Pony actually as an example, what is the latest update? Yeah.
Yeah, you are very correct. Actually, the loss of life, which is possible, and it has dramatically improved. But loss of property will rather increase, that is over the whole world, because most fertile lands in the coastal area, and most of the people they like to stay in the coastal area. So therefore, many infrastructure, all the big cities, all developed generally coastal area, and therefore economically the loss is increasing. But I don't know exactly that the ways are to reduce to certain extent, but it is always a thing actually which requires some concentrated effort. Like suppose you have told like the rice crop, generally October, November is the cyclone season. And then in Odisha, suppose you get only having one cyclone, perhaps one, sometimes two, but generally one cyclone for October, November. So therefore, it is very difficult to tell the farmers that go to short crop of paddy or so, which they can harvest before the cyclone season. Otherwise, actually that loss of applicable because you cannot stop any component of the hazard, that is the strong winds, heavy rainfall, and storm surges. All three have to occur because it is a natural process and we cannot stop it. Only we can take the precautions. The precaution wise, of course, now most of the coastal area we have the Pakka roads, and most of the coastal area the houses have become actually from Kacha house to Pakka house, so that the house collapse have decreased. But some awareness is required for people, like not to put plant like the coconut tree close to the house, which will definitely break many times, and so on, and how to save the life of the animals. This is the first time also we are so happy that this cyclone Dana time, Odisha government also taken care of with the animals. to take as much as possible to take to the safe side. So all these things actually possible to some extent stop the loss of the life of human being and to some extent the other animals. But reduction of the loss due to the strong wind and this thing, it is very difficult issue. And in fact, economic loss, if you see, it is gradually increasing because coastal area is very rich area because of the fertile lands. And people have to plant the trees and so on. And unless they will change their habits, suppose go for rice to that of the millers or so, which is 60 days crop, compared to rice, which is the 4 months crop. It may be difficult because by the nature of the people, rice is a staple food, and people will not like to go to short-lived food. Plants like millet, like mandia, millet, which you can grow in 60 days. Actually. So if that is done in monsoon time, perhaps they will not wait for the rice crop, which is generally mature in the month of November and early December.
Thank you, sir. Thank you.
Very minor thing. So I could see that the trajectory of the cyclone all along whatever we have shown is a kind of a linear graph. Like linearly goes and prediction models of the 10 models. Is there any cyclone which has a non-linear motion, like it's moving and come down and then goes up? So that, and the second question is, if that happens, then is it possible in the future that we can create an artificial kind of a pressure so that we divert it back to the ocean, so that the entire thing will be protected? I don't know. This is a kind of
So I think this is a very interesting question. It's one thing actually, due to nature of the Earth's rotation, a cyclone have to move in northern hemisphere to north and southern hemisphere to south, because the current force and we can that is by nature. That we cannot stop the rotation of the Earth. So not one. Second, that the direction of movement also depends upon the steering current we got in the tropical region. Steering current, the Earth rotates from west to east. The wind blows from east to west. That we call easterly wind. So therefore, cyclone have to move westward. But in spite of that, we have the recurvature of the cyclones, as you told exactly, and cyclones also overcoming land. Also sometimes, like Odisha super cyclone, it can move to Bhubaneswar. Then after that, they move southward. So that also possible, but that is when a complex interaction takes place with the topography, coastal region, and all things. So, but recurrent cyclones, which are generally stay more time in the ocean and make up the more havocs because they stay more times. That type of cyclone comes. Then a cyclone moving northwestward to east coast of India, but they move towards Myanmar or they move towards Bangladesh. Most of the cyclone will be Bangladesh and Myanmar. They're quite intense because they are lifespan in the ocean, quite compared to crossing the east coast. And those things also very well.
I have a question. Am I audible? Hello?
Yeah.
Sir, this is Madhulata from IMD New Delhi. Thank you very much for a nice elaborative talk. I have a question. Actually, in the changing climate, what is the difference in seasonal distribution and frequency of tropical cyclones in Bay of Bengal particularly?
So as I have shown you in one of the diagrams, actually what is happening, that is also all over the world also happening. That is because of the changing of the climate or global warming, what is happening actually, the temperature of the air is increased, so holding capacity of moisture is increased. So we get a lot more number of intense cyclones, but weaker cyclones number is slightly decreasing. So as a result, total number of cyclones is decreasing, but category 4 and 5 cyclones are increasing.
Sir, I have one more quick question in addition to this. So, sir, in this warming climate, how the physical mechanism of tropical cyclone is changing? Means which you showed so many things of the physics. So, because of the warming of temperature, what physics exactly?
Yeah. So what is happening if you warming, you know that the holding capacity of water in the atmosphere it depends upon the temperature. Because the saturation point comes, which is directly proportional to temperature. So if the temperature is more, then the holding capacity of moisture will be more.
Yes.
So if you hold the more moisture, then obviously that will be released. So and that is the main mechanism of carrying the heat from the surface to that of the middle troposphere. So theoretically also it explains that if we have warming there, we will have more heavy rainfall or more intense cyclone because it needs more heat, because it go on holding. But then if your holding is more, then you will not get more systems, but like about the Arabian Sea, we are getting many more cyclones now, because earlier Arabian Sea basin where we are not getting many cyclones, because in the monsoon time it cooled down due to low level jet. But because of the warming of the ocean, Arabian Sea, you got the cyclone like Gono, which are quite intense, almost a super cyclone that you got because of the warming of the ocean. The warming of the ocean along with the atmosphere in the climate change scenario allows some cyclone to develop, even where it was not developing earlier. So that is one thing happening. And as I told, that number may be gradually little less of the cyclonic disturbances, but cyclone intensity is increasing.
Sir, this is the Anup
Thank
from
you, sir. Thank you.
IMD New Delhi. Sir, I have a question. May I ask, sir?
Yeah, sure.
Yeah, sir, does presence of aerosols over oceanic region have any impact on intensification of cyclone?
Yeah, it depends upon the type of the aerosols. And if aerosol like dust cloud, or aerosol like a sulfate cloud, or aerosol like black carbon, it has different effects. So obviously, if we have some aerosol, which are hygroscopic aerosol, then it will be suitable for the precipitation. But if you have a dust cloud and other thing, it has a different impact. And definitely it has a lot of impact, and we have more so things we saw in the Arabian Sea, where, as I told you earlier, we don't have many cyclones, but if we see recent years, the very good intense cyclones we are getting also in the Arabian Sea.
Thank you so much, sir. Okay, I would like to thank you, sir, again. And now I request Dr. Manorama Mohanty to felicitate our speaker and Vice Chancellor, sir, also. अरे ठीक है
वो सेब वही वाली है वो वही था
हाँ, So thank you so much, ma'am. May I now request Dr. Manorama Mohanty to propose vote of thanks on behalf of IMD.
Thank you. On behalf of India Meteorological Department and India Meteorological Society Bhubaneswar chapter, I am privileged to deliver the vote of thanks to all who have made the event successful. I extend our heartfelt gratitude to our distinguished speaker, Professor C Mohanty, sir, for sharing your valuable insight and expertise with us today. My sincere thanks to Professor P.K. Nanda, sir, Vice Chancellor, SOA University, for your help and support at various stages for arranging this event. I express our gratitude to you, sir, for your kind words. I am very much thankful to our Honorable Secretary MOES, Dr. Ravichandran, sir, for making him available for this event with his busy schedule. I'm also very much thankful to all the organizing committee members of SOA. I would like to thank all the esteemed participants present physically and virtually as well. I am very much thankful to Professor G.K. Panda, sir, Chairman IMS Bhubaneswar chapter, and all the members of IMS Bhubaneswar chapter, and all scientists and members present over here. I would like to thank at last to our DG IMD Dr. Mrityunjay Mahapatra sir for his continuous support, and also thankful to our IMD team. I wish to thank you who involved in this program. Thank you so much. Jai Jagannath. So it is over today. So we can quit ourselves. Thank you so much. The members who are present here physically, they are invited for the flag, please.
Thank you, madam.
Yes, most welcome.